Did you know that about 1/3 of Mars below the surface is covered in ice? And if we look at this image of dusty cliff wall, we can see an ancient ice buried just below the surface. This light blue line is the ancient ice. And on this image of steep scarps, we can see an exposed sections of nearly pure water ice. The height of this one scarp is about 60 meters and thickness more than 100 meters. Two other scarps about the same size. And I think that this whole area is the same pure water ice. This image also shows us an exposed section of thick sheet of underground water ice. The height of this scarp is about 80 meters. This blue area also indicates that there is a subsurface ice in this place. And this is an image of the recent landslide. The blue color are layers of underground ice which is slowly sublimating as it is exposed to the atmosphere. On this image we can see deposits of dry ice on the surface of Mars. This enhanced turquoise color is a dry ice. Unlike on Earth, dry ice naturally exists on Mars' polar regions, and it forms in the fall and winter time, when temperatures are so cold that 30% of Martian carbon dioxide atmosphere freezes onto the ground. This image shows a thick layer of dry ice on the impact crater. Size of this crater is about 900 meters across. And this image shows us sand dunes from Martian North Polar regions in the process of seasonal defrosting. The white material is fine-grained frost. These circles called fans, and it's a dirt that pop out from under the layer of dry ice. Mars polar region is covered with an approximately 1 meter deep layer of dry ice, and every Martian spring when the sun begins to warm the surface, the trapped heat transforms the ice at the bottom to gas and building up pressure until it's burst through. When that happens, the gas flows out in geyser-like fashion and carries loose sand and dust with it, which then deposited on the surface in a direction determined by the wind at the time of the eruption. This polygonal terrain have been nicknamed spiders. Such terrain forms when dry ice below the surface heats up, turns into a gas and carves channels in the ground. This particular image shows previously eroded channels filled again with dry ice. In the summertime, whole ice will disappear into the atmosphere and we will see just eroded channels. These small, incised networks of narrow channels called gullies. They form when material driven by dry ice or melted subsurface ice flowing down from the Alcove. They are widespread and common features on the Martian surface, and mostly occurring on steep slopes between 30 and 50 degrees latitude in both the northern and southern hemisphere. This is an image of a gully on a slope that completely frosted during the winter time in shadow. And this is a giant sand dune gully from a Kaiser crater. The shape of this gully looks like a whale or mermaid tail. The width of this gully is about 60 meters and length about 250 meters. These lines on the sand dunes are the tracks left by sliding dry ice blocks. When warmed, dry ice block sublimates. This creates a cushion of gas beneath the block that makes it very easy for the block to slide down the dune slope. This ending pits is where the dry ice block stops and sublimates a whale while resting in place. These crisscrossing black lines on the ground are the trails left by dust devils. Dust devils on Mars form the same way that they do on Earth, and like on Earth, dust devils move across the Martian surface, exposing the darker subsurface rock. Many of these tracks are more than 30 meters wide and extends more than 4 kilometers. This is how these rotating columns of dust looks from the orbit. The length of the shadows of these dust devils suggests that the dust plume reaches about 800 meters or half a mile into the atmosphere. And this is a giant dust devil with the size of a terrestrial tornado. Diameter of this dust devil is about 140 meters, and his dust plume height reached 20 kilometers above the surface. The continuous swirling column of dust reached about half that altitude. This is how active dust devils looks on Martian surface. This video was taken by a Curiosity rover with one of its navigation cameras. This dust devil is approximately 800 meters away and about 5 meters wide. This is a sequence of images with another dust devil that's scooting across the ground near Curiosity rover. And these pictures of dusty carrying whirlwind were captured by the rover Spirit. These bumps looks artificial, but they are sand dunes less than 100 meters across. This image shows us two types of sand dunes. The small dots dunes called Barchan, and they are upwind. The downwind dunes are long and linear. These unusual T-shaped dunes are similar to Barchan dunes, but the pointed tips of these dunes align with the dominant wind direction and deviate from its classic crescent shape. Sand dunes on Mars take many shapes and forms, and they serve to scientists as weather vanes. In this image, the ripples in the sand tells us how wind moving around these rock formations. Many dunes and ripples on the planet are active, but others are clearly inactive. This image shows us sand dunes that have turned to stone. How these dunes become indurated is still unknown. This image shows black volcanic rock sand dunes and inverted craters that stick up above the surrounding plains. Such inverted craters is found on Mars and Earth, where erosion has stripped away surrounding topography. These dark streaks are the dust avalanches. They are common on Mars and they form in relatively steep terrains. What triggers these avalanches is unknown, but they are most likely caused by the mass movement of loose, fine-grained material on over-steepened slopes. This is an image of impact that triggered such an avalanche. This streak is about 1 kilometer long. And this is an image of a trough with many slope streaks. This streaks formation is among the few known processes currently active on Mars. Scientists think they form quickly, more like an avalanche than dust slowly creeping downhill. On this image we can see how lava flow on Martian surface. Many channels on Mars were carved by water, but not all. Molten rock can also flow and create features that resemble stream channels. One way to distinguish a lava channel from a stream channel is that a stream channel will show small rocks, sand and other debris on its bed. This image shows lava crumpled against the upstream side of an impact crater. These are the pictures of pit craters, and they are simply sinkholes in the ground with near vertical walls. They form when surface materials collapse into the large underground cavities. Sometimes lava flows freeze on the surface but continues to move on the ground in lava tube. When volcano stops erupting, the lava in the tube drains away. It leaves the tube roof unsupported, and sometimes the ceiling of such lava tube collapses, making pit craters along the lava tube path. The origins of these cratered cones are uncertain, but scientists think they might be mud volcanoes. New studies suggest that mud on Mars flows like lava does on Earth, and European scientists conduct an experiment with mud under Mars-like conditions and found that when surface of the mud freezes, the interior flow remains liquid and continue to move forward under the protection of the crust. So this finding can indeed explain the formation and morphology of these pitted mounds. This image shows glaciers that moving down valley. Like on Earth, glaciers on Mars come in lots of different shapes and sizes. Scientists already have been identified over 1300 glacier-like forms in the mid-latitudes of Mars. However, today Mars is a very dry place for any glaciers, and any ice left on the surface would evaporate without ever melting. But recent studies suggest that in the past climate changes Mars have experienced one or more ice ages in the mid-latitudes. So present glacier-like forms may represent the degraded remains of a once large water ice mass that now covered with rock and dust debris. This sand ridge called Tars, and they are one of the most common landforms on Mars. Mechanism for their formation is not well understood. But one possible way for their formation is that larger grains like petals are rolled on top of smaller ripples. Then finer dust settles into the cracks, making the tile larger than typical ripples. These cracks are observed in many locations on Mars. They form when temperature changes over the course of the year cause ice in the ground to expand, contract and break. The ground moves fractionally every time this occurs,